Hello everyone. Today we are going to look at comparison of fractions. Now in certain exams, direct questions are asked when a given fractions are arranged in ascending order or descending order, which is going to be the highest fraction, which is going to be the lowest fraction, which fraction is the third from the bottom, which is the third from the highest, so on. But comparison of fraction is a very important tool as far as data interpretation section is concerned. As the time passes by, the value and weightage of data interpretation has increased, the complexity of data interpretation questions have increased. So having a good command over comparison of fractions improves your chances of scoring much more as far as data interpretation section is concerned. Now first of all, let's understand what a fraction is. Now fraction is, let's take an example, x by y. This is a typical example of a fraction. X is called numerator and y is called denominator. Now numerator can be greater than denominator, numerator can be less than denominator. The only thing important here is denominator cannot be 0. If it is 0, it becomes undefined. So let's see how we can compare fractions. Now what are various types of fractions? There are basically two types of fractions. One is proper fraction and one is improper fraction. Now you guys must be wondering, what about mixed fraction? There's also a type called mixed fraction. Mixed fraction is nothing but how we represent improper fraction. It is not a separate type of fraction, but it is a different representation of fraction. So what is a proper fraction? Proper fraction in which numerator is less than denominator. It is called as proper fraction. And if numerator is greater than denominator, it becomes improper fraction. For example of proper fraction, let's say 3 by 5, 7 by 11, 9 by 25. These all are examples of proper fractions. Improper fractions, we can write it as 5 by 3, 11 by 7, 25 by 9 and so on. How to convert an improper fraction to a mixed fraction? Now 5 is greater than 3, so 5 can be divided by 3. It goes 1 times, the quotient is 1, the remainder is 2 and the divisor denominator remains the same. Here it is 1, 4 is the remainder and 7 is the denominator. Here 25 when divided by 9, it goes 2 times, that is 18, remainder is 7 and denominator remains the same. So 1 2 by 3, what does this mean? There is nothing but 1 plus 2 by 3. No sign is there, that doesn't mean it is a multiplication sign. It is 1 plus 2 by 3, that is written as 1 2 by 3. Now let's analyze this further. Now this is a proper fraction. A mixed fraction has an integer part along with a proper fraction part, because remainder is always going to be less than the denominator. So we have an integer part and a proper fraction part. The value of proper fraction is always less than 1 but greater than 0. So proper fraction is always less than 1, greater than 0. The value of 1 plus 2 by 3 is going to be between 1 and 2. The value of 1 by 4 by 7 is also going to be between 1 and 2. However, the value of 2 7 by 9 is going to be between 2 and 3. So let's say I need to compare 1 2 by 3 and 1 4 by 7. So how should I compare it? Should I compare 5 by 3 11 by 7? Should I compare 1 2 by 3 1 by 4 by 7? Now let's need to understand, it is 1 plus 2 by 3, it is 1 plus 4 by 7. One part is common to both. So 2 by 3, if it is greater, then this fraction is going to be greater. If 4 by 7 is greater, then this fraction is going to be greater. So at the end of the day, if they have the same integer parts, what we are going to do is, we are just going to compare the proper fraction part. There is no point comparing the integer part as they are same for both the cases. However, if we bring 2 7 by 9 into the picture, so this is nothing but 2 plus 7 by 9. Its value is going to be between 2 and 3. However, these two are going to be between 1 and 2. So obviously these two are going to be lesser than 2 7 by 9. So we are going to use this basics to see how we can compare fractions. Now let's say we have a fraction called x by y. If you want to take an example, we can take as 5 by 11. Now this is a proper fraction. Why getting proper fraction? As we have seen in case of 1 4 by 7 and 1 2 by 3. They both are same, 1 and 1. We need to compare the proper fractions only. The proper fraction, greater the proper fraction, the greater the whole fraction is going to be. So instead comparing the whole thing, we are just going to compare the proper fraction. So comparison of fractions can also be termed as comparison of proper fractions, because it can be diluted to comparing just the proper fractions. Now I have a proper fraction x by y, for example 5 by 11. If I add certain quantity to it in the numerator as well as denominator, let's say I add a 2 here, so 5 plus 2 plus 11 plus 2, so this becomes 7 by 13. Now what is greater, this is greater or this is greater? So when you add certain quantity in the numerator and the same quantity is added in the denominator, the fraction in which the quantity added is going to come is going to be greater. That means 7 by 13 is going to be greater than 5 by 11. Similarly, take any example. Add 1, 6 by 14 is going to be there. This is going to be greater. Add 5, 10 by 18 is going to be there. This is going to be greater. Now how we can get this? The difference between 5 by 13 is 8. The difference between 10 and 18 is 8. If the difference remains the same, you can just increase, you can arrange it in the increasing order of the numerator. So you'll get the increasing order. But please mind it, the difference between the numerator and denominator should be the same. If, let's take example, as we have taken 5 by 13, if it is not same, let's say I increase the numerator by 5 and increase the denominator by 3, then what? Then also the fraction that is coming second is going to be greater than the first fraction. Basically, if we have a proper fraction x by y, if we add something to numerator and add something to denominator, the second fraction is going to be the greater fraction among the two. However, if we add two different quantities to numerator and denominator, but the quantity added in the numerator is greater than the quantity added in the denominator, then also the second fraction is going to be greater if A is greater than B. The quantity added in the numerator is much more than the quantity added in the denominator, then the second fraction is going to be the greatest. Okay, now again, while comparing fractions, we need to look at certain things which I term it as common sense. Let's look at it. Five by 13 and 5 by 17, which is greater? Now obviously the numerator is the same, here denominator is increasing, that's why this number is going to decrease. Similarly, if we have 5 by 13 and 7 by 13, here the denominator is same, numerator is increasing, that's why the number will increase. This is going to increase, here denominator is increasing, the number is going to decrease. What happens in the case when numerator is increasing, denominator is decreasing? Numerator will increase, the number should increase. Denominator is decreasing, that means number should again increase. Denominator when was increasing, the number was decreasing. However, when denominator is decreasing, the number is going to increase. So this increase is taking the fraction upwards, that is going to grow. this decrease is also taking fraction upwards. That is, this is going to be greater. So when both the effects are combined, the net fraction is going to be greater than the fraction that we are comparing with. Similarly, if numerator decreases, that let's say it's become 4, a decrease in numerator will lower the number, that means it should be less than the comparing fraction, and denominator increases, let's say 15. Increase in denominator also decreases the value. So this is also decreasing individually, this is also decreasing individually. So combined effect will be, the fraction will be lower than the original given fraction. However, there are certain cases in which a numerator may increase and denominator may also increase. Let's say an example, 5 by 13 is a numerator, that proper fraction that we have taken. Numerator increases, the value should increase, but denominator also increases. Let's say it becomes 15, the value should decrease. So here it should increase, here it should decrease. In such cases, we cannot determine whether the value should increase or decrease. Then we need to go to an extensive method that we are going to look at in a few minutes. We are going to look at example. We have been given 5 fractions. We need to arrange them in ascending order. The fractions are 16 by 11, 26 by 21, 32 by 27, 28 by 23 and 37 by 32. Now if you look at it, the difference is 5, 5, 5, 5, 5. If the difference is same as we have seen before, what we can do is we can arrange them in increasing order. But the point to be noted here is these all are not proper fractions. Those points that we have seen is for only proper fractions. So as these are improper fractions, we convert them into proper fractions, mixed fractions. So this becomes 1 5 by 11, 1 5 by 21, 1 5 by 27, 1 5 by 23, 1 5 by 32. Now, as each and every fraction has an integer part 1, what we need to do is we need to compare just the proper fraction. When we compare the proper fraction, 5 by 11 and 5 by 21, numerator is same, denominator is greater, that means this number is going to be smaller than this number. This number is going to be smaller than this number and this number. This number is going to be smaller than 21 and 11, but it is going to be greater than 27. And 32 is the largest of the denominators, so it is going to be the smallest of the numbers. So we get this is as the smallest number, second as this, third, fourth and fifth. However, if you would have done directly, the results would have been just the opposite, because 37 is the highest, you would have placed it first. But please mind it that this method is for proper fractions, not for improper fractions. Let's look at another example. We have one more example for you. 23 by 15, 9 by 5, 41 by 20, 52 by 25 and 29 by 14. So we need to arrange them in ascending order. Again, the numbers given are, as you can see, improper fraction. So first of all, our duty is to convert into mixed fraction. So this will become 1 8 by 15, 1 4 by 5, 2 1 by 20, 2 2 by 25 and 2 1 by 40. As you can see, these two numbers have the integer part as 1. So their value will be always less than 2. But these three numbers are having integer part as 2. So these numbers are always going to be greater than 2. So these two are going to form the bottom two rungs of our fractions, and these three are going to be the greater fractions. So now let's compare these two, which is the smallest. Now 8 by 15. So we need to compare only 8 by 15 and 4 by 5. So 8 by 15, 4 by 5 can also be written as 8 by 10. Now the numerator is same. If the denominator is greater, the number becomes smaller. So this number is the smallest and this is just greater than this number, because these three numbers are greater than 2 and they are going to be greater than these two numbers. Similarly, what about these three numbers? Here it is 1 by 20, here it is 2 by 25, here it is 1 by 14. The integer part is the same, so we can ignore conveniently integer part as of now. So this can be written as 2 by 40, 2 by 25 and 2 by 28. Again, as you can see, the numerator part is the same. So just by comparing the denominator part, we can see the greater the denominator, the smaller the number. So this is going to be the smallest among these three. So this is going to be third. This is going to be the next. So this is going to be fourth. And the denominator is the smallest. That means the number is the greatest. So this becomes 5. So here what we have done is we have just manipulated the numbers and made the numerator same in both the cases. However, the point to be noted here is these two are going to be smaller than these three. Here we are comparing the fractions of numbers which are falling in the category of having 1 as the integer part, and here we are comparing the fractions which are falling in the category having the integer as 2. So this is how you can do. But again, the questions that are going to come won't be very simple, they won't be this simple. Let's look if the questions are complicated, how to go about it. Let's take an example. If you have 2 by 15, 14 by 135, 23 by 160, 33 by 184 and 46 by 239. So we need to compare these 5 fractions, again which is the smallest, which is the greatest, or let's say let's arrange them in the ascending order. So as you can see, all of them are already in proper fraction. So nothing can be done. What we can do is we need to take, this is same as 1 by 15 by 2. This is same as 1 by 135 by 14. This is same as 1 by 160 by 23, 1 by 184 by 33 and 1 by 239 by 46. Now as you can see, the numerator is the same for everyone. What we need to do is we need to compare the denominator. The greater the denominator, the smaller the number is going to be. But what is the value going to be? Again, the bottom part, this part is improper fraction. Let's convert into mixed fraction. This will be 1 7, 1 by 2. This is going to be 1 by 9, 9 by 14. This is going to be 1, 6, 12 by 22 by 23. 33 5s is 165. So this will be 5, 19 by 33. And 46 5s is 230. So this is going to be 5, 9 by 46. So now let's see the denominators. What are they? Denominator is 7 point something, 9 point something, 6 point something, 5 point something and 5 point something. Now these two are in the same category, however these three are in the different category. The numerator, the denominator for these two are going to be the smallest. That means these two numbers are going to be the greatest. However, here the denominator is the greatest. That means this is the smallest number. Then the value of this is the greatest. Then this comes. And this is the third least number. What about these two? Here it is 5 plus 19 by 33 and 5 plus 9 by 46. As you have seen, 5 is common to both. So what we can do is we can ignore 5. If we ignore 5, this fraction becomes 33 by 19 and 46 by 9. When we take reciprocal, 1 divided by 9 divided by 46, 46 goes up, it becomes 46 by 9. So the value of this is 114 by 19 and the value of this is 5 1 by 9. So obviously 5 1 by 9 is greater than 114 by 19. Now as you can see here, the numerator was 1, the values were in denominator. But as we have taken the reciprocal, the values are coming in numerator. So number is greater, here if the number is greater, the original number is going to be greater. Here if the number is smaller, the original number is going to be smaller. So this is smaller of the two and this is greater than the two. In this way, what you can do is you can calculate, compare fractions quite easily. However, only catch here is you should be good in calculations. If you are not good in calculations, or if you are very slow in multiplying things or adding up things or subtracting things, then it might take up time. So you need to practice a lot. The main use of this method is going to be in data interpretation section, where calculators are not involved, as well as the calculations that are there is quite intensive. Thank you.